All right, so this is chapter 8, self-test. And we're just going to run through a good bunch of these numbers here. So starting on number 1, multiple choice, but we should be able to do this ourselves. This is the product property. When you multiply similar bases, you add the exponents. Okay, so this is going to be letter A. This is x to the 11th. We don't multiply them. We don't do anything. We don't add the coefficients. Okay, so you can see A and C. They both have the 11 exponent, but here they added the coefficients of 1 and 1 to get 2. That doesn't make sense. Coefficients are multiplied, 1 times 1. Exponents are added. So it's x to the 11th. Number 2, we're going to rewrite 5 to the negative third as a fraction. So since it has a negative 3 exponent, that means we need to fix it. So we put it to the bottom of the fraction, so it becomes 5 to the positive 3. We need to fill in that empty space with a 1. And then we're going to go ahead and actually do 5 to the third, which is 125. So it's 1 over 125. And if we actually ran that in the calculator, so 5 raised to the negative third, you get this. And if we did 1 over 125, you get the same answer. So you can see that these are equivalent to each other. All right, number 3, we're going to order these from least to greatest. So first of all, let's go ahead and actually find out what their values are. So negative 4 times negative 3, that's positive 12. Negative 3 raised to the 4th. It's going to be a big positive number. So negative 3 raised to the 4th. I know it's positive because there's an even number of exponents here. If it was an odd number, it would create a negative. But every 2 negative times a negative makes a positive. All right, so that's 81. And then on that last one, okay, this is going to be a really small number. Negative 4 raised to the negative third. Let's think about this. So first of all, we need to fix this. So this is going to be 1 over negative 4 to the positive third. All right, and then since it's to the third power, we know that this will end up being a negative. So negative 4 raised to the third. Make sure you're putting it in parentheses. It's negative 64. So we get 1 over negative 64, and you can put that negative out front. This is a negative number. So if I'm going to go ahead and put these in order, obviously this would be first. So 1 over, and I'll put the negative out front, 64, and then 12, and then 81. And of course, you could match those up. So it's actually negative 4 raised to the negative third, and then negative 4 times negative 3, and then negative 3 raised to the 4th. That's them now actually in order back from what we started with. Okay, number 4, we're going to simplify square root of 600. Put that in simple stratical form. When I see 600, I know 100 goes into it, right? That kind of jumps out at me. And 100 is a great number. It's one of our perfect squares because 10 squared is 100. So if I go ahead and split this into 100 times 6, I got 600, right? Well, the square root of 100 is a perfect square. It's 10. 10 times 10 is 100. And I still have square root of 6. And you always want to double check, do I have any of the perfect squares in this? And I don't. So I'm done. Okay, number 7. Pretty basic stuff here. We're going to add our exponents. So that's y to the 6th. Number 8. On these, we make sure that the coefficient actually gets raised to the third power. So 10 to the third is 1,000. It's 10 times 10 times 10. And then we multiply the exponents when we raise a power to another power, and so that's m to the 6th. Okay, number 8, basic quotient property. You subtract your exponents, and that's a to the 12th. That was number 9. 10. All right, we have a quotient raised to a power. So everything inside gets the power, the numerator and the denominator, because really what this is m over 6 times m over 6 times m over 6. So you're going to get 3 of these and 3 of these. So it's m to the third. It's the same as writing m to the third over 6 to the third. everything gets that exponent. Now m to the third doesn't change. 6 to the third, we should go ahead and get the number, and it's 216. And there's that. And we're going to number 12 here. So 11, another pretty basic one. G to the fourth times G, which is to the first. I'm going to go ahead and write that. G to the second. They're all being multiplied, so you're just adding straight across. The 0 doesn't add anything to it, so it's going to be 5 of these. So that is G to the fifth. And number 12. Now one with a little more complications. All right, so first thing that I would recommend is simplify the bottom. Go ahead and multiply here, that's 8. And then you're adding exponents, so that's 4. So that gives us this. 6 divided by 8 will be a decimal, so we leave it a fraction, but we simplify it. Divide by 2, we're going to get a 3, and we're going to get a 4. Think about like you've got 2 ends here, and you've got 4 ends here, so 2 on top, cancel 2 on the bottom, but you're still going to have 2 down there. So end of the second stays on the bottom. All right, 16. So we are going to rewrite this without parentheses or negative exponents. So how do we do that? All right, so first of all, just like we did up here when we were looking at a quotient raised to a power, everything's going to get the negative 3. So we're going to get 3 to the negative 3, and then when it comes in here, you're going to multiply. That's y to the negative 6. You multiply because it's a power raised to a power. Now, before you start trying to do anything with those, let's go ahead and fix them and make them positive. So I'm going to go ahead and take this and move it up. So I have y to the positive 6 up top. I'm going to take this and move it down, and I have 3 to the positive third on the bottom. Now I don't have to deal with negatives. 3 to the third is 27. So it's y to the 6th over 27. And I'm all set. So if you tried to put 3 raised to the negative third, you're going to get some nasty decimal, and so you're going to be confused. Well, what do I do with that? So don't ever punch in those negative exponents. Move them, make them positive, goes on the bottom there. All right, to 21. Distance between the 2 points. Just a basic distance formula. All right, so it's the big square root. You're going to subtract your x's, square it, and you're going to subtract your y's. Square it, add them together, take the square root. All right, so the x's, I'm going to go this direction. 9 minus 1 squared, so that's going to be 8 squared. That's going to be 64. And with my y's, same direction. 5 minus negative 10 squared. That goes plus plus. So 15 squared, that's 225. Got to put those together. We get 289. All of this is still under that square root. And if I go ahead and take the square root of 289, it is a perfect number 17. And I don't have to do anything else fancy. I'm going to squeeze some stuff in here on this page. So we're going to go to 24. So you have a square with a diagonal that's 12 meters. So let's go ahead and draw this real quick. Square means all the sides are the same. And you have this diagonal, which is equal to 12. Now, if I know what this side is, I know what this side is, because it's not just a rectangle, it's a square. All right, so we want to know what's the area of this square. All right, so we've got this, and then we've got this. And so here's what we know. Since this is a right triangle, first of all, let's talk about why I used x and x for a second, because you might be like, well, how'd you come up with that? So this is an unknown. We don't know the side lengths. It wasn't given to us. But I do know that the two sides are the same. So I wouldn't call them x and y or a and b. They're the same. And I also know that the area of a square is x times x. So my area is going to be base times height. So x times x, which is x squared. So if I can figure out what x is, I can go ahead and find the area. You just multiply it times itself. So how am I going to do that? Well, since the square has a right triangle, I'm going to go a squared plus b squared equals c squared. Looking at that triangle, my c squared is going to be 12. So I have x squared plus x squared equals that. Well, that comes out to 2x squared when you add those together. All right, when you're adding them, you just add the coefficients, just like x plus x is 2x. 12 squared is 144. So we're going to go ahead and divide by 2. And so 144 divided by 2 is 72. So I know x squared equals 72. Now, if you want to get deeper into it and you're just trying to find the side length, you'd have to square root this, right? But square root of 72 is not a nice number. Oops. Square root 72, not a nice number. So you could, of course, simplify it into simplest radical form. But remember, we already established area is base times height, x times x, x squared. So whatever x squared is, not x squared, that's the area. We already established right here, x squared equals 72. So I can plug that straight in for x squared. And so I already know the area of this square is 72. Nothing that difficult on the test, but just stretching you a little bit there. All right, and 25 I'm going to squeeze in right here. In some states, a license plate consists of 2 letters followed by 4 digits. Those are numbers. How many different license plates are possible that fit this description? And then just a reminder, they're nice that they remind you of this. There's 10 digits because you got to remember 0, 1 through 9, and 0. So you have to pick 2 letters, 4 numbers. 1, 2, 3, 4. And let's keep a little separation here so we don't mix them up. So for the letters, we got to say, how many letters are there in the alphabet? You got 26 and 26. So it doesn't say you can't choose the same letter. If they did, after you choose the first one, there'd be 25 to choose from because one wouldn't be allowed. But we're assuming you can pick any letter that you want. So it's 26 times 26. And then you can pick 4 numbers. And again, it doesn't say that you can't repeat them. So those would all be 10s. So you could simplify this if you wanted to. That's 26 to the second because we are going to multiply all this together to find the total combinations. And this is 10 to the fourth, but you also could just multiply straight across and get what you need there. So it's just a nice big number. I messed that up. 6,760,000. But the easiest way again to do this is put the blanks. How many things do you have to choose from in each one? And just multiply straight across. If you want to simplify, you will get the same answer either way. But we're always going to get a nice big number there.